As a continuation of the 5.7 to 6.3 summative, still working with simplifying polynomials. You can see D, we are subtracting. So as we've done all year in subtracting, I'm going to add the opposite. So instead of subtracting this, I'm going to add a negative 5x cubed, a positive 4x squared, and a positive 3. Then I'm going to combine like terms. So I have 2x cubed and a negative 5x cubed. It would be a negative 3x cubed. I have a negative 5x squared plus 4x squared would be a negative 1x squared. I have a negative 7x, and that's it. And I have a negative 4 and a positive 3, which gives me a negative 1. So add the opposite, combine like terms. If it was just addition, you would just add the opposite. Division of polynomials. Here we're dividing by x plus 3. I can do this synthetically by putting a negative 3 out in front. Then listing the coefficients. 4, negative 3, negative 2, 1. And then the process would be to bring down the first number, multiply, and add vertically. And then multiply negative 3 times negative 15 is a positive 45. Then add. Then multiply again, which is a negative 129. And then add, which would be a negative 128. That is your remainder. The 43 is your constant. The negative 15 would be your x term, and your 4 would be your x squared term. So that would be the answer by division. The negative 128 we would put over the divisor, which is x plus 3. In the next problems, we're studying the degree. The degree is the largest power of the variable. The leading coefficient, which is the number in front of the largest power. The constant is the non-variable term, and end behavior is what it's doing on the ends. So for number 5, the largest power is 4, that'd be the degree. The leading coefficient, the number in front of the power of 4, would be negative 4. The constant's the term without the variable, which would be 5. End behavior, this is an even degree, and it is a negative leading coefficient, which means it's going to go down shaped like this, which means on both ends, this means the left end, it goes to negative infinity, and the right end, it also goes to negative infinity. That's because it's even with a negative leading coefficient. Number 6, the degree would be 3. That's your largest power. Leading coefficient then is the 2. The constant's the non-variable term, which would be the 4. This is odd degree, positive leading coefficient. So it's going to look like this. This means what's it doing on the left-hand side? It's going down, that'd be negative infinity. What's it doing on the right-hand side? Going up to positive infinity. Next problem, finding p of negative 2 and p of 3 for the following function. Synthetically, if you're doing p of negative 2, you simply put a negative 2 out in front. You would list the coefficients. And then it's the same process of above. Bring down the negative 3. Multiply these together, which is a positive 6. Add, which gives you 5. multiply again, which is negative 10, add, which is negative 14, multiply again is 28, and add would be 33. 33 would be what p of negative 2 would equal. To do this directly, we would put negative 2 in for x. You could easily do this on your calculator. Should also get 33. Doing p of 3, we would list those coefficients. Again, bring down the negative 3, multiply and add, multiply and add, multiply, and then adding would be 107. Directly again, we would just put 3 in for x. And if you did that, you'd get the same answer. 8a and b, we talked about these a little bit above. This one is odd degree, positive leading coefficient. Its general shape would be like this. Second one is even degree, negative leading coefficient, so its shape would be going down. Okay, the other shapes would be, if it's even, with a positive leading coefficient, it would open up. If it'd be odd with a negative leading coefficient, it would go down. Those are your 4 general shapes of those.